Let's look at curve tracing of polar curves. Let's see with an example. F of r comma theta in this form. So let us say r is equal to a times 1 plus cos theta. Okay, first let's look at the symmetry. Change theta to minus theta. Okay, so r is equal to a1 plus cos minus theta. Now cos minus theta is nothing but cos theta. So there is no change. So it is symmetric about the x-axis. Now change theta to pi minus theta. So what do we get? R is equal to a times 1 plus cos pi minus theta. Now in this case what happens? Cos becomes minus. So it becomes 1 minus cos theta. So not symmetric about the y-axis. Now change theta to pi by 4 minus theta. So r is equal to a times 1 plus cos pi by 4 minus theta. Now again here this cos pi by 4 is not going to be equal to cos theta. So not symmetric about y equal to x line. Change r to minus r. So minus r is equal to a times 1 plus cos theta. So r becomes a minus a times 1 plus cos theta. So which means again this is changing. So not symmetric about the pole. Okay. We have looked at symmetry. Now let's look at when r is equal to 0. A 1 plus cos theta. Theta will be what? 1 plus cos theta equal to 0. Cos theta equal to minus 1. So which means theta is equal to minus pi. When theta is equal to 0, r is equal to a times 1 plus cos 0. A times 1 plus cos 0 is 1. So 2a. When theta is equal to pi by 2, r is equal to a times pi by 2, not 6. A times 1 plus cos pi by 2. A times 1 minus cos pi by 2 is 0. So certain things that we have found is that this is r, this is theta. So we have found this point 2a and we have found this point a. And since this is symmetric across the x-axis, on this side also minus a. So we have got 3 points. What we can do is go to our old method theta and find the r for that. So let's start with 0, pi by 6, pi by 4, pi by 3. These are, remember, standard ones. Pi by 2, 2 pi by 3, 3 pi by 4 and 0. Now many of them we have already done it. So when theta equal to 0, this is 2. When pi by 2, it is a. When it is 0, it is minus pi. Now let's find the remaining ones. When theta equal to pi by 6, r is equal to, now here let's say a is equal to 1, pi by 6. So 1 plus cos pi by 6, 1 plus pi by 6 is root 3 by 2, which gives us 2 plus 1.732 by 2. This gives us 1.866. So let's say 1.87 or 1.9. 1.9. Now theta is equal to pi by 4. So r is equal to 1 plus cos pi by 4, which is 1 plus 1 by root 2. 1 plus root 2 by 2, which is 2 plus 1.414 by 2, which gives us 3.414 by 2. 2 ones, 2 sevens. So this gives us 1.7. Now pi by 3. You got the idea now. So I'll just write the results. So when theta is equal to pi by 3, this is 1.5. When theta is equal to 2 pi by 3, r is equal to 0.5. So pi by 3 is 1.5, 2 pi by 3 is 0.5, 3 pi by 4 is 0.3. Okay, so we have got some more points and we can plot them. Let's plot them. 2a, let's say this is 1a, and here what we are going to do is pi by 6, pi by 4, pi by 3, pi by 2, right? So when it is pi by 6, now remember, since our choice of ordinates, say for example this is r and this is theta, so we have to go for the theta and its corresponding r. So when it is 0, it is 2. So when theta is 0, it is 2. So here, when it is pi by 6, when it is pi by 6, it is 1.9. When it is pi by 4, it is 1.7. Then comes 1.5. Then comes 1. And then comes, what about pi by 2? Pi by 2 is a. So this is going to be a. So this is the point. So what we have got is this part of the curve. Now let's look at 2 pi by 3. 2 pi by 3 is this which is nothing but equivalent to pi by 3. So this is going to be, let's say, 1, and this is going to be 2. So if it is 2 pi by 3, 0.5. 2 pi by 3 is 0.5, and 3 pi by 4 is 0.3. 3 pi by 4 is nothing but pi by 4. So that is 0.3. Okay. Yes. So this is our curve above the x-axis. But we know that it is symmetric across x-axis. So which means we just find a point A here and repeat the yes. So this is our curve. Now what we could also do is we could look at the slopes. If you want to make it more perfect, what we figure out is beta. That is the we know that is nothing but tan beta equal to r d theta by dr. R is a times 1 plus cos theta. Br by d theta is equal to minus a sin theta. R d theta by dr. So here we are doing two operations in one shot. D theta by dr. We are taking the reciprocal of this and multiplying it by r. So minus r by a sin theta. Now r is nothing but a times 1 plus cos theta. So a cancels. Now 1 plus cos theta can be written as 2 cos square theta by 2 by sin theta can be written as 2 sin theta by 2 cos theta by 2. 2 this one of it goes off. cos theta by 2 by sin theta by 2 is nothing but cot theta by 2. Cot minus tan pi by 2 plus theta by 2. So tan cancels, beta is equal to theta by 2 plus pi by 2 plus theta by 2. Yes, so say at theta equal to pi by 2, we will get a horizontal. Then we will get the tangent angle will be something like this. Then angle will go something like this. Then it will go like this. Then it will go like this. And all this is basically the angle between the radius vector. This would be something like this. This is the radius vector. This is the yes. So accordingly we can plot. And here remember, when it is minus pi, the radius vector is 0. So it starts from 0, goes like this, goes like this, goes like this. And then it is just a question of symmetry on the other side. So that is curve tracing when the curve is in polar form. I think that's enough for today. Bye for now.